I have to run this simulation vertical for it to show up properly on my screen, so you may need to enlarge your screen or open this video in a new window. A few weeks back, or it could have been last week, depending on where you were in the course, we talked about soluble salts. And table salt, NaCl, is a soluble salt. And when you add a soluble salt to water, all of the ions break apart into positive and negative ions, and they're all dissolved in there. You've also seen this when we've talked about electrolysis, and we've put a light bulb on there, the soluble electrolytes. Those are all playing in here. That's all soluble salts. And in that case, we could just figure out, well, if both ions were neutral and they formed like a strong acid or a strong base with water, they wouldn't stay together in water, and you'd have a neutral solution. If one of them had a charge, what that would mean, it would be like maybe the green ones would grab the H from the water, maybe, and leave left some of the time and leave leftover OHs flying around, which would make a solution basic. And the reverse would happen to make it acidic. So that's when we were talking about salts. Now, we are switching gears. This is the last bit of our K everything. If you're sick of K, this is the last bit of it. And in some ways, I feel like it's easier than all the other Ks. Now we're going to talk about slightly soluble salts. So up to this point, we had talked about insoluble salts, and there was a solubility chart, and we wrote insoluble salts with a solid, actually as a solid. But like everything in chemistry, we kind of teach it one way, and then we go back and like kind of sort of like update it. And we're like, oh, well, actually, but really, and so we kind of didn't tell the whole truth last time. Insoluble salts, the ones that make solids at the end, dissolve a tiny bit in water. Just a tiny bit, not a lot. So I'm going to jump to thallium sulfide. I'm going to put some of that in. So you see how, like, for the most part, it stays together, but a little bit dissolves? It seems like such a tiny bit. Seems like it doesn't matter, right? Except that if that is, you know, thallium, which isn't so great for our body, and a tiny bit of it does get in the water system, and only a tiny bit of it can mess you up, it suddenly matters, right? So our wastewater treatments, also in our body, how our body processes slightly soluble things, you would be surprised that the little tiny quantities that we're talking about, these Avogadro scale numbers, you know, 1 in a billion, can matter. And so that's why we have a little unit on this section, these slightly soluble salts. Now, slightly soluble can look soluble a little bit. So let me show you. That one is one of the more insoluble ones. Let me jump to strontium phosphate. So look, it looks like that's soluble, right? I only shook it a little bit. That's not really very many molecules that are in that water. Let me add a little bit more. And look, do you see how most of it is insoluble? You won't have to use a simulation like this. We'll tell you, hey, it's soluble or it's not soluble. You can also use, you'll see the KSP chart to tell if it's insoluble, but slightly soluble is what that word is now. We don't say insoluble now, we say slightly soluble. I know. Anyways, so this is still a slightly soluble salt. It's just that it's a little bit more soluble than the last thing. And then I'll show you one that's even a tiny bit more soluble. But again, on the scale of things, let me jump over actually to the copper. You don't want just this stuff just floating around. So look, see, that looks kind of soluble. Let me put a little more in. And a little bit more in. Nope, it's going to take a little more than that. Finally. Again, though, like if I had a way to show you the number of water molecules and I could like flick that on, you would see that the number of dissolved ions compared to the number of water molecules in there, it's like very, very, very tiny, but it matters. So this is insoluble salt, and this is how they look.